Hello and welcome to section 2. We're going to look at face recognition. We'll start by looking at how face recognition works, how we will approach it for our purposes, and look at some examples from OpenCV and Amazon's recognition capability. We'll then move on to looking at how we can do face recognition in a streaming video. In this video, we're going to look at how face recognition works. First of all, we need to get our environment set up. For illustrative purposes, I'm going to use the label faces in the wild dataset. Although, if you want, you can use any other face database that you have. The LFW, or label faces in the wild dataset, is available as part of sklearn, but the images are much smaller. So we want to take advantage of a good-sized image, and the download at that link is 250 pixels for each face. You'll also need to download the text file that contains a list of the names of faces in the dataset and how many images there are in each one. Again, if you're using your own dataset, you might want to create this kind of CSV or index file for use later. To simplify things, there is a download_lfw.sh script which will download all of the files that you need and put them in the right locations, in this case in the LFW directory. For the AWS recognition video, you'll also need an AWS account and a credit card. I spent about 20 cents when creating this module, so even with extensive testing, I'd be very surprised if your spend exceeds a few dollars. However, at this point, I would stress it's important to set up billing alerts at a level you are comfortable with, and to shut down or delete anything you no longer need once you no longer need them. Please note that some AWS charges are for storage and not just for usage. For the final video in this module, you'll also need a webcam. I'm using the one built into my laptop for this, but any USB webcam that is capable of making a Skype call will work. With one eye on a future section, if your PC doesn't have a built-in microphone, then it's worth getting a webcam that has a built-in microphone. So let's start by just looking at the difference between face detection and recognition. Sometimes these terms are used interchangeably, but in essence, face detection identifies a face in an image, and you can see that in the top left picture. Here, we just have a red box that says, there's a face. Face recognition identifies whose face that is. And as you can see in the bottom box, it's been recognized with a high level of confidence that face is Dan Aykroyd. So how does face recognition work? Well, this is a typical approach, although there are some variants out there. First, we take an input image and align the face in order to perform feature extraction. In this example, we're suggesting that the features could be the location of the eyes, the mouth, etc. The shape, size and distance of these features from each other is often used as a unique identifier for faces. We turn this information into a vector, which is a series of numbers, and match this against our database of known faces in order to determine whose face this is. In the example at the bottom, you can see on the left an image of me. How we align that image, we extract features relating to the position of my ears, nose, eyes, mouth, etc. We match that against a database of pre-trained features, and at the end we're confident that that picture is of me. We can extract features using a number of different approaches. We'll look at histogram of orientated gradients today, or HOG as it's often known, although you can use Haar cascades or even a convolutional neural network, which we'll look at later. So let's look at a histogram of orientated gradients. Simply put, HOG looks for gradients in an image, and faces have a fairly defined pattern that can be picked up. So let's see HOG in action. To show HOG in action, I've created a Python notebook. As we step through this, first of all we'll import any relevant Python libraries. We'll load an image from our LFW dataset to work with and convert it to grayscale. In this example, we're going to use an image of Jackie Chan. There you can see our image. Now we'll perform feature extraction using HOG. And we'll display the image of Jackie Chan with a visualization of the HOG vector. Here you can see an outline of a face, and this is the HOG representation or visualization of Jackie Chan's face. Let's look at some more examples. For this, we'll use more faces from our LFW dataset. Here we can see the names with lots of images against them. You can see that George Bush has 530 images, for example. Let's pick 10 at random and display their HOG representations. Here you can see examples. It should be fairly evident now that there's a common pattern emerging in the faces, and you can see this as we scroll through the rest of them.